Hello everyone, welcome back to my channel. Today in this video we are going to discuss about the concept of relocating loaders. Already I have made a video with respect to the concepts of program relocation. If you don't have idea about what is program relocation, why program relocation, please watch the video and get back to this. Okay, before getting into the video, I request my viewers who have not subscribed yet, please subscribe and continue to watch. Okay, what is a relocating loader? Loaders that allow for program relocation are called relocating loaders. Okay, what is the motivation behind the relocating loaders? The motivation is very simple. Every mission is given a larger memory or a maximum memory, and simultaneously the programs are sharing the memory. So when a new program comes for execution, that moment operating system supplies the new memory address from where the program or the new application is to be executed. So many programs are running in parallel. That is why there is a efficient sharing of memory is happening. So this arises the need of relocating loaders. Relocation, in fact, is one of the mission dependent features. I'll tell you why it is mission dependent with examples. Okay, there are two methods for specifying relocation. One is modification record and another one is relocation bit. Okay, when to use modification record and when to use the relocation bit, that we will understand with an example. Okay, we know that in system software we are studying two architectures. One is SIC, another one is SIC-XC. First we see one example from SIC-XC. I request viewers to kindly ignore the scribbling part. Okay, now look into the program. We know that SIC-XC architecture supports four types of instruction. Out of that four types of instruction, the format 4 instruction, which is of 4 bytes in length, directly gives the space for storing the address. Okay, now just look into the object code. From the object code only we can easily identify what format instruction it is. The first one is format 3 because we have 3 byte object code. The second one is also format 3 and the third one is format 4. Fourth one is format 3. This is format 3 again format 4 and likewise. So from the object code itself we are able to identify easily the format 4 instruction. Okay, now consider one example of format 4. So look into this object code 4B101036. In that the last 5 half bytes is nothing but the address of the label. So what is there at 1036? Okay, 1036 must have the address of the read record, isn't it? Yes. The address of the label read record is nothing but 1036. That is why while generating the object code for this instruction, the address also has become part of the instruction. So this is the similar story for every format 4 object code. Right. Okay. Now, how the relocation impacts when the same program is reloaded from another memory address. In this case, the starting address of this program is being given as 0000. Right? Please kindly ignore the scribbling part. Just look into the printed format only. This program is starting with the address 0000. Suppose the program is relocated to the address 5000. Which are the instructions will get affected? In SIC-XC program. In SIC-XC program, the only instruction or only format instruction that is getting impacted during relocation is format 4. For other instructions, the object code remains the same irrespective of wherever it is relocated. Okay, so how it is getting impacted, that is what we are going to see now. Now I'll explain with the modification record. Okay, now for this SIC-XC program, I'm going to write the object code. So how do we write the object code? Object code contains 3 types of records: header record, text record and end record. But to reflect the modification, we are going to include the modification record also in the object program. What is the structure of the modification record? This is a structure. Column 1 contains the letter M. Column 2 to 7 contains the relocation address. I mean the where the relocation is to be impacted. So that will be there in the 2 to 7. 8 to 9 is nothing but the length, which is reflected in half byte, and column 10 might be either plus or minus, and column 11 to 17 is going to be the relocation address or the segment name or the new starting address. Okay, now that we will understand with an example. For this given SIC XC example, I'm going to write the object file. So any object file, it contains the header record. So header record begins with the letter H followed by the program name. For writing the program name, there are 6 columns, but the program name is copied here, so other 2 columns are left blank now. After that, we have the starting address of the program. The starting address of the program is given as zeros. Okay, for that 6 columns are reserved. After that, there are 6 columns which is going to tell the length of the program. For example, let me take the length of the program is 107A. Okay, so header record is created. After the header record, we have to write the text record. So how to write the text record? Every text record begins with the letter T, followed by the starting address of the text record. For that, we have 6 columns. Right, after that there are 2 columns where we will be writing the length of the text record. After that, we will be writing continuously the object codes, isn't it? Maximum how many object codes we can store? 10 object codes, provided if each object code is of 3 bytes. Or we can remember that a text record can be of maximum length of 30 bytes. Okay, now let me write the object code one by one as given in the program. Now in the given program, the first object code is 17202D, and the second one is 69202D, and the third one is 4B101036, then 032026, etc. Okay, in a text record, how many object codes we can write in a single text record? This is of 3 bytes. This is 3 plus 3, 6 bytes. 6 plus 4, 10 bytes. Again 13. This is 16. This is 19. Okay, 20, 21, 22, 23. Up to this is 23. This is 26. 29 bytes, right? So maximum in this text record, we can store the object code up to 032010. So 032010 is the last last object code in this particular text record. Okay, roughly I write the length of the text record is 1D. Right, this is the length of the text record. I have to write the text record here. So I can generate as many as text records according to the length of the program. But what is required here? To reflect the relocation, I have to write the modification record as per this format. So how do I write the modification record? Modification record begins with the letter M. Column 1 contains the modification record, and the relocation address will be available in the next 6 columns, isn't it? But relocation address will be known only at the time of relocation. Now it is not known. So now the once the relocation address is known, where it should be reflected, that address we have to write here. For example, let us consider this object code. We know that this object code is for format 4 instruction. When the relocation happens, the address 01036 is to be modified. For example, currently the starting address of the program is 0000. Suppose the relocation address becomes 5000. What will be the address of read record? The address of read record, the address of read record, just a minute. Yeah, the address of read record will become 6036. So if this address is modified as 6036, obviously here also my object code, how it should get modified? 4B106036. This is how my object code is to be rewritten. So how do I reflect this modification in my object file? So how do I do that? So once the new starting address is known, I have to say that the modification has to happen at the address 0000007 for 5 half byte length, plus the new address will be available in the label copy, because copy is the label for the starting address. Right, now I'll tell you what is the 0007. Okay, now once again look into this object code. Right, what is the address of this instruction? This address of the instruction is 0006. So this 4B is available at the address 06. This 10 is at the address 07. This 60 is at the address 08. This 36 is at the address 09. Okay, then 5 half byte length, because this is the address, isn't it? This is the address to be modified. So what is the address of this part of the object code? It is starting from 07. So that is why we are writing the modification record in such a way that modification has to happen from the address 0007 for the next 5 half bytes. What is the modification to happen? The value of this label copy is to be updated here. That is the meaning. For example, if the program is relocated to the new address, then the label copy value will become 5000. That 5000 value must be added to the address. Okay, now let us see one more example. Consider this object code. We know that this is also format 4 instruction. So what is the address of this instruction? Its address is 0013. When this object code is relocated, obviously this last 5 half bytes will get modified. So how do I convey in the form of a modification record? I have to write with the letter M. Since the starting address of the instruction is 13, the modification has to happen from the address 14 for the next 5 half bytes. And what is the modification to happen? The copy, the new relocation address is to be added in this. Okay, now in SIC program, the modification records are required only for the format 4 instruction. Suppose you take a program of 100 instructions, maximum 10% of the instructions will be format 4. So for those 10% of the instructions only, we need to create the modification record. Okay, what about SIC program? Right, so let us see now one example with respect to SIC program. Okay, consider this SIC program. In SIC program, we know that there are two instruction formats, and both the formats are containing the address. Either it is direct addressing mode or it is indexed addressing mode. Look into the first object code. The first object code is nothing but the hexadecimal equivalent of EOF. The second object code is a hexadecimal equivalent of this word 3. The third object code is also just zeros. Okay, now look into this object code 141009. Every instruction in SIC program is 3 bytes, and we know that last 15 bits is for address. So obviously this 1009 is the address of some label. Let us see what is the label. Yeah, 1009 is nothing but the address of the label written address. That is why when the instruction contains a label written address, this is being converted into the object code. While being converted into the object code, its address is written. Now come to the second object code 48203D. 203D must be the address of the label read record. Let us check it out. Yes, read record label appears here and its address is 203D. Okay, now move on to the third object code 00100C. 00 is the object code for LDA. What is this 100C? 100C is nothing but the address of the label length. Must be the address of the label length, isn't it? Let us check now. Yes, length label is here and its address is here, 100C. Okay, now let us check one more object code. 281006. What is this 28? 28 is nothing but, yeah, it is equivalent to the instruction compare, right? Okay, what is this 1006? 1006 is nothing but the address of the label 0. Okay, then let us check this 0C100F. What is this 0C? 0C is nothing but the opcode for the instruction STA. What is this 100F? 100F must be the address for the label buffer. Yes, buffer label is here and its address is 100F. So what do you understand from this? In SIC program, most of the object codes contain the address as a part of it. So when the SIC program is relocated, every object code is to be modified. Suppose SIC program contains 100 instructions, maybe some 8 to 9 instructions may be the just object code for the data, and the remaining all are instructions. And is it possible to write modification record for all the remaining 90% of the instructions? No, it is not possible. That is why we claimed that relocation concept is one of the mission dependent feature. For SICXC, relocation can be achieved with the help of modification record. But for SIC architecture, relocation can't be achieved with the help of modification record, because suppose 90 instructions required to be relocated, it is highly impossible to write 90 modification records. So what is the solution for this? The solution is introducing the concept of relocation bits. So what is this relocation bit? The relocation bit is present as a part of the text record itself. Now there is a slight change in the architecture of the text record. Column 1, it begins with the letter T. Then 2 to 7 is nothing but the starting address of the text record. As usual, 8 to 9, the next two columns is nothing but the length of the text record. Then this is the modification happened in the text record. Column 10 to 12, in fact 3 columns are used for relocation bits. Then from 13 to 72 we are able to store the object codes. Once again, maximum we are able to store 10 object codes, which is equivalent to 30 bytes size. Okay, now for an SIC program, I'll just show how to write the text record as well as a relocation bit. Okay, this is the SIC program, isn't it? Okay, how to write the object file for this? As usual, first we need to write the header record. The name of the program is copy. Of course, for storing the name of the program, there are 6 columns. We have used only the 4 columns. And the starting address of the program is being given as 1000. So let us write it as 001000 because 6 columns are there. Afterwards, we need to write the length of the program. Let me write roughly now 107A because this is not a big botheration as of now. Okay, now let us write the text record. Text record begins with the letter T. After that, we have to write the starting address of the text record. What is the starting address of the text record? 001000. Then we have to write the length of the text record. As of now, I'm not writing anything here because I don't know how many object codes I will accommodate in the text record. So I am leaving it empty. After the length of the text record, we have to reserve 3 columns for relocation bits. Relocation bits also let us fill little later. Then after the length, after the relocation bit, we should start accommodating the object code, right? So what is the first object code present here? 454F46. The second object code is 000003. The third one is all zeros. Right. And the fourth one is 141009. And the fifth one is 4820 3D. etc. Likewise, how many object codes I can accommodate? Let us count here. This is 3 byte. So 10 object codes we can accommodate, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for my first text record, the last object code what I can accommodate is 302012. So totally 30 bytes of object codes are accommodated. So what is the length of the text record? Length of the text record is 1E. Okay, 30 bytes if you convert into hexadecimal, I hope it is 1E. You can cross verify that. Okay, next there are 3 relocation bits. How do we convey these object codes require modification at the time of relocation using the relocation bits? So if you look into the object codes, the first 3 object codes does not contain the address. It is just the hexadecimal equivalent of these words, isn't it? So if an object code requires modification, I write the bit value as 1. If it does not require modification, I write the bit value as 0. So for the first object code, no modification required. For the second object code also, no modification required. For the third object code, no modification required. From the fourth object code till the 10th object code, we require the modification because every object code contains the address as a part of it. So let me write it here. 1, then 1, 1, 1, 1, 1, 1. Totally 10 object codes only, right? Let me count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Leaving the first 3 object codes, all the rest of the object codes require modification, isn't it? Okay, now combine the bits 4 as a group of 4. Now find the hexadecimal equivalent of this. For the first one, it is 1. For the second group of 4 bits, it is F. For the third one, it is C. Now update this in this 3 column. 1FC. So this is how the relocation bits are to be written. If the object code does not require any modification at the time of relocation, set the bit value to 0. So first 3 object codes we have written as 0. From the 4th object code till the 10th object code, we have set the relocation bit value to 1. Then from the beginning, group the bits as a group of 4 bits and then find the hexadecimal equivalent. That will become the relocation bit. In the similar way, we can create the rest of the text records till the end of the program, and finally we can write the end record, which contains the starting address from where the program is to be executed. I hope you have understood. Once again, I want to remind you that relocation is one of the mission dependent feature. For SIC-XC, there is no much relocation impacts the object codes, whereas with respect to SIC program, every other instruction is getting impacted because of relocation. That is why for SIC-XC, we go for modification record concept for SIC-XC, and we go for the relocation bit concept for SIC architecture. Thank you.